wabarakatuh. My name is Fatin Atikah binti YAC'COB and I am from J4 EE1113A1. Okay, for today's video for my subject ELE232, I'm gonna show how I solve a problems that I have got the question from the lecture. And for this question, this is about the FET, and this is the question that I get. It shows that the DC parameters of N-channel D MOSFET is shown in figure Q1. So this is the figure Q1 that I got. As you can see, there are a few resistors, capacitors, and also voltage, and also one FET. Okay, for this question, I have to solve from two analysis. That is from DC analysis and also AC analysis. For the DC analysis, I have to solve two problems. That is the first one and the second one. Okay. For the second one, the question is to find the drain current IDQ and also the DC gate source voltage VSQ. For these two questions, we use the DC analysis. Okay. For the first thing that we need to do when we are making DC analysis, first we need to open circuit all of the capacitor. So from this capacitor, this one and also this one, we need to open circuit all of them. So when we open circuit all of this voltage and also resistor is not counted because we already open circuit here. Okay, and we only get 4 resistors. Okay. From the question, it is given the formula to find the ID. That is IDSS times V1 minus VGSQ over VP power 2. Okay. From the question, it is also given the value of IDSS and also VP. Okay, what I have done is, first thing first, I need to find the value for ID. So I use the formula that given, that is IDSS times Y1 minus VGS over VP power of 2. So we get 8 milli times V1 minus VGS over negative 4 power of 2. So from here, we need to construct a table to find the value of ID. For the ID, we get the value for in milliampere. Okay. I use this formula to find the value for ID, and as you can see on the screen, this is the value of ID that I get. That is 8 milli. That is when the value of VGS is 0, I get the ID is 8 milli. When VGS is negative 1, I get the ID is 4.5 milliampere. When the VGS is negative 2, the value for ID is 2 milliampere. When the VGS is negative 3, the ID is 0.5 milliampere. And lastly, when the VGS is negative 4, I got the ID is 0 milliampere. And then by constructing this table, I need to do the graph table. So this is the graph that I got. Okay, sorry. Okay, this line, the curve line here, from negative 4 VGS to the 8 milliampere. This one. I'm sorry if you can see it. Okay. But that is not the answer for IDQ. Okay, next, after we have sketched the graph, we need to find the next thing. Okay, what we can get from this, what we can see from this figure Q1, we can see that 110 mega ohm and also 10 mega ohm is parallel together. So for these two resistors, we need to use the Thevenin theorem to find the value of them. So the Thevenin theorem is, we use RTH is 110 mega with parallel with 10 mega. So we get the answer is 9.17 mega ohm. And then for using Thevenin theorem also, we need to find the VTH. The VTH is 1.67 volt. Okay, so I redraw back the circuit. So we only got 3 resistor and 2 voltage. Okay, this is the circuit that I got. This is the RTH, and also this is the VTH. So next we use KVL to find the VGS of the circuit. We know this is the gate 1, drain, and this is the source 1. Okay, so VGS is from gate to source. So we use KVL from VTH to the RS. Okay, so the KVL is negative 1.67 plus 9.17 mega times IG plus VGS plus 1K IS equal to 0. Okay, from here you can see that I cancel the IG because in the MOSFET the IG is equal to 0. So this we cancel this one. So VGS is equal to 1.67 minus 1K ID. Okay, next from the equation that we get here, we need to construct another table. Okay, to find the VGS next. From this equation, we have constructed the table, and here we get when ID is 0, the VGS1 is 1.7. When ID is 2 milli, we got the VGS is negative 0.3. When ID is 4 milliampere, we get the VGS is negative 2.3. And then when ID is 6 milliampere, we got the VGS is negative 4.3 volt. And then after constructing this table, next we also need to sketch the graph. Okay, from this table we will get a straight line graph. Okay, this is what I have constructed. This is the line. Okay, from the graph that we got, there is a place that they will meet together from the both of the graph. Okay, then we will get it from the place that they met together. Then we will get the value of IDQ and also VGSQ. So from this graph, from all the work that we have done, the answer for IDQ is 3.35 milliampere and VGSQ is negative 1.55 volt. Okay, that is the answer for using DC analysis to find the drain current and also DC gate source voltage. So we have done with the first and second question. Okay, next for the third question. For the third, fourth, and also fifth question, we need to use the AC analysis. Okay. Okay, for the first thing first, but by using AC analysis. Before that, before using DC analysis, we need to open circuit the capacitor. However, in AC analysis, we need to short circuit all of the capacitor. So we need to short circuit this capacitor, and also this capacitor. Okay, what can we get when we short circuit all of the capacitor? We will need to use this resistor. Before this, we didn't use this capacitor, this resistor. Now we will use this capacitor, this resistor. Okay, from this CS, we already short circuit this CS. So the current will flow from here to here. The current will not flow through this 1K resistor, because they have another easy way to flow. So we will not count this, we will cancel this 1K resistor. So I have redrawn the circuit. This is the circuit that I have redrawn. Okay, what you can see here, we will know the configuration that we will use. From here, we can see that there is no resistor in the source thing. So we will call this as the common source bypass configuration. Okay, they are given this formula for GM. Okay, we will use it to find the GM. That is 2 IDSS over VP times it with 1 minus VGS cube over VP. For the VGSQ, we will use the VGSQ that we find. We find that is negative 1.55 volt. So when we count it, we have known that GM is equal to 2.45 milli. Okay. Next is the AC equivalent circuit. Okay. This is the standard AC equivalent circuit that we get from the equation. Okay, so the third question is we need to find the input impedance Zin. This is the Zin. Okay, so the Zin is from here and also here. So we only need to parallel it. So 10 mega parallel with 110 mega is equal to 9.167 mega ohm. Okay, that is the Zin. The next question is to find the output impedance Zout. Okay, for output impedance, we need to set the voltage input as 0. So there will not be any current that will flow. So Zout equal to RDS parallel with RD. So the RDS is equal to infinity and RD is 2.2K. That is given in the question. So the Zout is equal to 2.2K ohm. That is the fourth question. And for the last question, we need to find the total voltage gain AVS. Okay. First, before finding AVS, we need to find the AV. The formula for AV is Vout over Vin. From this circuit, we know that Vout is equal to negative GM VGS times with RDS parallel with RD. Here, this one. Because we be looking from here, and this is the Vout. For the Vin, this is the equation. We get the Vin equal to VGS. So from the question that we get, so the V out is negative GM VGS times with RDS parallel with RD. V in is VGS. We can cancel VGS and then we get negative GM times with RDS parallel with RD. So the answer that we get is negative 5.39K for the AV. Okay, after we finding the AV, we need to find the AVS. AVS formula is V out over V in times with V in over Vs. We already find the V out over V in, that is AV. So we need to find the V in over Vs. To find AV, V in over Vs, we need to use the VDR. VDR from here. This is Z in and this is the this is the V in and so this is Z in. Okay, from that this is the circuit that we use. So VDR is Z in over Z in plus 750 times with Vs. So we move Vs to here. We will get the value for Vi over Vs is 1 volt. So from there we will get the value for AVF. AVF is negative 5.39K times with 1 equal to negative 5.39K. So the value for AVS is negative 5.39K. Okay, that is all. And that is the last question that we need to solve. Okay, that is all from me. And thank you for listening to my video. Okay, thank you and see you again. Bye.